Hello and an excellent evening. Today we have two devices here. One very nice looking, very clean bread bin, made in Germany with excellent feet, rubber feet, which are nice. The warranty sticker is not on here, but I'm not sure if it ever was. The serial number sticker looks just like new. Everything is super clean. There are a few burn marks from cables. The cables have softeners in them that melt the plastic over the years. There's a little bit of yellowing going on, but it's very minor. All in all, it looks incredibly nice. Same goes for the 1541. I guess those belong together. We'll see once we open these up. Both are defective, and they are not mine. They are here to be repaired. So this one here has a black screen, I was told. I didn't check it yet. And this one here has a continuously running motor. So if we turn this on, you can probably hear that. There is no LED going on, which there should, at least the power LED should come on, which already gives us a hint at what might be happening here. Because if the power LED doesn't come on and we have a continually spinning drive, it means that the 12-volt supply is fine because the motor is spinning, but the 5-volt supply is not fine. And if we are lucky, this is just a matter of another drive with a broken full bridge rectifier on the 5-volt rail, which is actually quite often the case. Those die because they get pretty warm, and after 40 years or something, they might break down. Luckily, I think I have those in stock, so if that is the case, it should be an easy fix. Of course, there might be other things broken. It could also be the voltage regulator, but I haven't seen those die yet. And there might be other things wrong as well. But if the power LED doesn't come on, I would assume that the 5-volt rail is broken. So what we're gonna do is we're gonna open this thing up. My god, it's heavy because it has the integrated transformer. And then take a look and measure a little bit. All right, this is the drive opened up, and it is in excellent condition so far. There are, of course, some usual suspects that you might want to check out and or replace, which are this tantalum cap here, this tantalum cap here. They might explode at some point, which is not catastrophic. They usually don't do much damage except for a loud bang. So it might be a good idea to replace them anyway. But I haven't seen them go off that often, at least on the 1541s. These are the full bridge rectifiers, and we'll check their outputs in a second. They output DC, obviously. I was on AC. Then what else is there to say? Most of the chips are socketed. The gate array is not socketed. So this is a assembly 250442, it seems, from mid to like second half of 1984, but rather in the middle, 32 week, 30th week. These are the ROM chips. One is by GI, the other by MOS. Then there's the SRAM, 7406, 7414, some inverters. Those also like to go bad sometimes, especially if you unplug the device while it's running. There's a bunch of other stuff here, but all the chips look fine. There's no MOS chips, no MOS logic chips, which are bad. Yeah, looking good. These are the voltage regulators. They are probably also fine. My guess is that if I measure here on CR1 and CR3, that one of them will be pretty much dead. Let's turn this thing on. So this here is CR1 and it outputs 1.2 volts, slightly going up, 1.345. And this here outputs 19 volts, which is the 12 volt supply, I think, that gets regulated down. This here is creeping up very slowly, and it might at some point come out of reset, but it's basically not working. So I would say that this is probably exactly what is broken. Another way to test this is to check in diode mode, because this is basically all diodes. So let's check. I mean, the voltage that we're seeing there is definitely not a good one. Question is, what else could be pulling this down? Let's have a look at the schematics. Okay, so this is the schematic for the board revision we are looking at. Especially this is the power supply here, and this is the AC input, as it says. Going through the fuse, which is obviously okay because otherwise you won't have anything. Going through the transformer, and then we have the two full bridge rectifiers. And I was assuming that maybe CR1, the one at the top, could be perhaps defective, but in diode mode it was reading just fine, which is interesting. And after that we get two capacitors, C4, which is a smaller one that I can see here, and C16, which is the large golden Fraco branded one. And then we go into the LM345, which is exactly what we have here in the 5 volt regulator. On its output, we should already see the 5 volts, which we don't. And especially we don't see that even on the input. So what could be the reason? The reason could be that, for example, the capacitor might need reforming. This whole thing has a lot of dust inside of it, cobwebs even, and a little bit of moisture, signs of moisture, I would say. Not really water ingress, but I would assume that it might have been stored in a basement or somewhere where it might be a little bit humid. What I would try to do is let it run a little bit and then check if it works, if the capacitors, for example, need reforming. Ideally, you would do that slowly, but we already turned it on and off a couple of times, but it might need just a little bit more time to come back to life. So that might be good news. So here we are. I try to keep it a little bit running, and after turning it off one or more times, look at that. It resets correctly. Even the power LED is now working. So if I'm going in here and measure our 5 volt bridge rectifier, it reads 11.31 volts, which is probably fine. We are on 230 volts here, so it comes in a little bit hot, but that's okay, and that gets regulated down to 5 volts, as should be visible if I probe here and probably here. I hope. Yes, 5.02 volts. The 5 volt regulator is working just fine. So my assumption was that the Fraco required a little bit of reforming. Those capacitors can be replaced. Some people say that the Fraco is not very reliable. I haven't had them explode or anything. Plus these large caps are obviously relatively expensive. My gut says I'm gonna leave it like that. What I am gonna do is I am going to very quickly clean the heads a little bit. I will dust off the cobwebs and see if I have to lubricate anything. I do see a little bit of corrosive stuff on the flywheel here, or if it's a flywheel, I'm not quite sure. but everything is turning fine. But after a short clean, I will attach it to my Zoom floppy and try to format a disk and read it back or something like that. That should do the trick, I think. Now we're inside, and you can already see, I need a pointing device. Here is some corrosion around the motor. That's the spindle motor, which drives a belt around a flywheel on the bottom. This here is the stepper motor, and this is also made from aluminum, I guess, because it also has this corrosion. Here at this wheel that grabs the what do you call it? That is the disk, the floppy disk. You also have something. Then you can't see that, it's not in shot right now. White around here, which hints to I don't know what. But first of all, and I get all this grime here as well, I recommend storing these devices, if possible, at room temperature and usual room humidity, like 40% at most, like your normal living quarters, if you can manage that. But storing these in the garage or in the attic or the basement is usually a bit dangerous, because it might lead to corrosion like this, and also it will destroy your floppy disks. Floppy disks don't like that at all. And I asked the owner to put in a floppy disk for transportation purposes so that the head doesn't get shaken around, which is this one here. I'm trying to show this. Maybe it comes across, but the media is a little bit cloudy, which means that there is probably some mold on there. I can't really twist it right now. The mold usually attacks the surface coating, so it might get ripped off by the read head. So I don't recommend storing disks outside of normal room temperature and humidity. I will try to remove a little bit of this stuff. I don't think it does a lot of harm. It might be corrosion, it might be mold, who knows. But it might be difficult to remove. Here on the plastic it removes easily, so maybe that is dust or mold. There were also a lot of spider webs in here. We could also modify this transformer to accept 230 volts. It's actually 220 volts. But there's another pair of pins. I could look up if these are the windings for 230 volts, which would reduce our input voltage to the regulators, which in turn would make them run a little bit cooler and hence prolong their life, perhaps. Interesting, there seems to be a little bit of Loctite on the washer here, because this washer here is usually spinning around and making funny noises in these kind of mechanisms. But except for all the dirt and the little bit of stuff that we're seeing, the drive is in very, very good condition. I would go so far as to say that only the storage conditions were not that great, but I think it was treated very nicely in its lifetime. It doesn't look very much used or beaten up. Here the white stuff doesn't come off, so maybe that is kind of like corrosion from high humidity. The transformer itself, the core, looks very clean. So I did see rusted but still working transformers, because the iron core is, even if it's rusty, it will work. So that's nice. We can measure the heads in a minute. The flywheel and the stepper motor look okay. Turning freely. I will wipe it down just once to get rid of the weird feeling that this gives me, thanks to the corrodedness. But there's not much we can do about it. I don't expect the drive to be in the need of much adjustments. They're usually pretty stable, so I won't touch the this part here, which is for aligning the heads, and the stepper motor you can twist a little bit to adjust the plate that you have here. So I think that should be fine. The board, let me zoom out a little bit, also looks relatively nice. There's a little bit of dirt here and there, but I'm gonna wipe down. Some of the ICs are a little bit dusty, but other than that, it's really nice looking. This is the capacitor that I talked about. This needed reforming, and reforming, it basically reforms by powering it on. Optimally, you would have to desolder it and ramp up the voltage very gently, which we didn't do, but the original owner already didn't do that. So I think the internal resistance limits the current that goes into this thing, and it just reformed on its own. The reformation process is basically, because these things are similar to batteries, so they have an electrolyte in there, and that might separate from where it should be, or decompose, or I don't know what. Some chemistry is happening, and when you apply a voltage, it actually reforms the electrolyte and the whole buildup of the capacitor, because it's basically a big loop of plastic and conductive material and liquid electrolyte. Yeah. One of these jumpers is actually for selecting the drive ID. I think these two here maybe, but we leave it at 8 because that's what normally you would use. Later 1541-2 will have dip switches to select that. Okay, there's even a little bit of dirt coming off here. I think this is good enough. I would now put this back in very roughly. That's supposed to be. And we're gonna very quickly check the heads if they are good. And if that's the case, we can test the whole thing. All right. There are 4 wires, and they all need to measure below, let's say, 50 ohms, pairwise tested. So this one here is 26, which is fine. This pair is 16.7, which is also fine. 33, 27, and the last one, 17.4. So the head is good, which is quite expected. The ARPS drive usually don't die with open coils in their heads, but the Mitsumi drives do. They are very fragile and will mostly die because of, you could call it a manufacturing defect, but to be honest, they lasted many years before they died, and they were for cheap home computers, so I think it's fair to say that they lasted long enough. That these drives here last 4 decades is actually quite amazing, and probably not at all expected. For some extra rigidity. So there's nothing made of metal underneath here, because I will leave the frame open like this. I suggest you don't do something like that at home. Because of course there's mains voltages inside. But we will now attach the Zoom floppy, which is this magnificent device. It lets you attach IEC bus type devices to your PC, Mac or whatever, but also IEEE devices like the bigger Commodore drives that I featured in some of my other videos. So it just gets plugged in here, and then the USB lead, of course, into your PC. And we'll take a random old disk. It is not rotten. And turn on the device. And then I'll run a detect command that you can't see. And it actually detected a 1541, which is nice. So let's see if there's anything on the disk and if it can read that. That's looking good. Yes, that's actually working. Now let's try format. Head banging. Now you can see the drive head coming up here. Moving quite quickly because this is a quick format. And that's also looking very promising. Yeah, there we go. This is actually working fine. I would say this disk drive is good as new, more or less. I will put it back together, clean the case a little bit from the inside, and then we'll look at the C64. Okay, the 1541 is sitting here and it's up and running again. Check how to sit here so that you can see me. The C64 is on the desk. You can't see everything here, but I'm trying to display whatever this machine outputs down here. And let's check the power LED as well. We're turning it on, and the power LED comes on. And we do get a signal. I don't see the white bar at the left side, but since there's a video signal, I think the VIC is probably okay. It might be cut off in the capture device, but we don't see anything else. With the harness not yet connected, this is the diagnostic cartridge, which has dead test and diagnostic ROM, which should do something, and I'm gonna try and pull it up like so. We do have 5 volts and we do have the 985 kilohertz, but nothing else is coming to life, which is not a good sign. That could be quite a different amount of things. Power and clock being good is definitely a good thing. Now we have the dead test not running, which means we need to turn this thing open, which I'll do just in a minute. And there we are. The machine looks absolutely fabulous. This machine has the ROM soldered. It has a MOS PLA, which is already basically smoking gun. This could very well be the MOS. Let's see. We do have some other issues here. So the CIAs are soldered down, which is okay. The CIAs are from 11th week and 4th week of 1984. Interesting. Seems to be a real jumble. It is a 250407, which seems to be very fitting for this period, I would say. The CPU is soldered down. The ROMs are all in sockets, which is nice. The SID is in a socket. The PLA is in a socket, which is very good because those die all the time. Most of the logic chips are original. There is one MOS thing here, which we might replace just because, and there's another MOS 7707 over there, because the Morse logic chips were produced with very, very shoddy quality. And I must really say that they usually don't work very well. My next step would be to check if the CPU comes out of reset, or we might just go for broke and replace the PLA. I think that might actually be very easy to do. It could also be corroded sockets or something, because I do see the white stuff here on the screws actually, that we also saw in the other device, in the floppy drive. So it might very well also be corroded sockets. So what I'm gonna do is I'm gonna spray some contact cleaner into all of the sockets and then reinsert the chips firmly, making sure that no pin is being bent out of shape. I'll do that very quickly and then we'll check the machine again. Actually, I remembered that the MiniPro utility for the TI-8662 and its successors can test the PLA of a C64 if you specify the 906114 device, and we'll just very quickly do that. And there you go, logic test failed, 6 errors encountered, which means that this is a broken PLA. My guess is that if we replace that, we will already see signs of life. The question is, will everything work? There could be still problems with the ROM, the CPU could be bad, all kinds of things. The SID might be damaged, but this won't probably stop it from running. And I still want to replace the MOS TTL logic chips, because those are prone to fail, and I don't want to see this machine back in the near future, so I think it's safe to desolder this and replace it. I do have some GAL-based PLAs that I will use here, so let me quickly grab that. There we go, very easy fix. I put in some deoxit or Kontakt and tuner spray, as we say in German, and I put in the GAL PLA. This is one I soldered myself, bought these little PCBs very cheap from Eisler, and installed 2 GALs on there programmed in the same programmer that I just used to test the PLA. This should hopefully bring this thing back to life, let's see. And still nothing, which is interesting. But there could be other things that are wrong, obviously. I'm gonna insert the dead test cartridge, set to dead test actually, and see if it outputs anything. Not really. This could, of course, still be another issue. Sorry for bumping here. Let's check the voltages, if the 12 volts are actually okay. If the VIC doesn't get all its voltages, it might also have an issue. So this should be the 5 volts, I think. It is, I can't see that. Let's put that over here. So this is 5 volts. These should be 12 volts, which is fine. So those are there. Next up would be to maybe pull out the DAS test max to see if it can boot, but the dead test usually should show signs of life as well. Could very well be a dead CPU, one of the dead MOS chips, because then we don't get access to the RAM, which would be obviously a bad thing. ROM chips are getting slightly warm, which is kind of a good sign, because it means it is working. But other than that, yeah. The clock speed is drifting very slightly, but I don't think that's necessarily an issue that's on the last digit. So yeah, let me grab the DAS test max and see if that gets anything. Okay, DAS test max is here, and that also doesn't show up anything. Could of course also still be a broken VIC-II chip. Next up, what I want to try is, I only deoxidated this one here because it was defective. I would deoxidate all the chips, including the VIC-II, because you never know if all this corrosion did anything. I will take the board out because that makes things much easier. So be right back. I put deoxide in every single socket. Everything has been cleaned. I even took the lid off the can for the VIC-II, which is fine for a short amount of time. There is a cooling thingy on there. You could just leave it off and put a regular, like, I don't know, aluminum or copper cooler on there, but that's fine. For now, I will also put this back into place. Let's turn this on and see if it does anything different. And it doesn't. Because it probably isn't these sockets. Let's double check with the Desk Test Max. The whole thing doesn't come out of reset, which means we have to bring out the big guns. We are going to take the oscilloscope out and try and see if we can make any sense of this machine. Maybe we can see if it comes out of reset or if there are any activity at all, especially on the CPU data and address pins. Okay, everything is soldered out, and I can show you. There are now sockets in there, and we'll replace that. The 7707 is a 7406 compatible, and or LS06, and the 7712 is a 74LS08. I think I should have both of them in stock, but first we will test both chips. So here you can still see the result of the defective PLA, and indeed it had 6 broken logic values in line number 11 or something. I don't know what that is. So yeah, that was of course bad. Now let's test the 7707, which is the 7406 replacement. And there we go. Oh no, we should test it as open collector, I think. Which is okay, which means that the NMI comes from something different. Nevertheless, I want to replace it. This is bad news, probably, because it could mean that either the CPU or the CIA might be at fault, I think, which would not be such a good thing. The 7408 is what kind of thing? It's a quad 2 input AND gate. So let's check that as well. So 7408 is also testing fine, which again is bad news. I was hoping that at least one of them is not a good chip. We will replace them, we will test and see what's happening. The always triggering NMI is definitely an issue, because I think if that is going high all the time and or like oscillating around the high level, that's definitely not a good thing. So yeah, let's try it out. Good or not so good. The thing is, we still have the weird NMI signal. And if I turn the machine on, we still have the black screen, obviously, and I can detect the NMI signal on the CIA, obviously, also on the CPU, and of course on the output of the 556. The 556 is not triggering, or let's say the 556 would be down here. This is the inverter. That's after the 556. But there's no input, it's low, and only here we have here it's low, and here we have the output getting dragged high by whatever chip. My assumption would be that it's either the CIA, because it could be only one of those, or the CPU. My hope is that it is the CIA, because I have a couple of those here. We could desolder the whole CIA now, but if it's not the CIA, it will be the CPU, and we need to desolder that and get a new one. So what I would now do is take these cutters here and cut pin 21 on the CIA. If it's not the CIA, we can resolder that and everything is fine. If it is the CIA, then there is no harm done. But I don't want to unnecessarily desolder this thing here if it is maybe the CPU. So I'm gonna cut this. There we go. Now it's open. Let's see if that changed anything. Let's turn it on. And sadly, I don't see any improvement. So I fear that it might be the CPU. So let's check down here. We still got the NMI flaking around like that. I fear, yes, I fear it is the CPU. Which means we have to replace it. I will solder back the lag here, which is not a big issue. And then I will desolder the CPU, and I will have a look if I have a replacement one in one of my C64s that I can borrow, that is not soldered in. And if that's the case, I will swap it in and see if that is fixing the machine, actually. Because I think there can't be much else broken. The NMI is really only generated by the 5F6 via the restore button of the keyboard, then inverted. Or it can be triggered by the CIA here, or by the CPU. And I think it's down to the CPU now. The deed is done. I have replaced the CPU, desoldered the old one, put a socket in here. I think you can barely see that here. Borrowed one, a good CPU from a different machine, an 8500, which should be perfectly compatible. And let's turn it on. And we still get the black screen. What about the NMI? The NMI this time looks fine. So we are doing something right. We do see activity on the CPU. We don't see the NMI all the time, which is probably active low, I would hope. Let's check that on the schematics. And the NMI is active low. Yeah, so that's just fine. We can live with that, so that's not active. But something else is still not happy. Maybe it's time to actually borrow a different VIC, but I'm still not that sure about the VIC. What does the DAT test say about the machine now? It is still seeing good voltages and it is seeing the clock signal, but nothing else. Is it trying to execute something? Probably. Some things look a little bit off sometimes. I mean, this looks like good data to me, at least, but very, very repetitive. This here looks more like what I would expect. But there's stuff like this where it looks like there might be some clashes or something. I might want to remove the ROM chips and see what that does to the machine. I think the DES Test Max should run without the ROMs, but the DES Test Max doesn't do anything either, right? So Let's remove the ROMs and check again. The desk test max is in, all the ROMs are out. Let's see if it can display anything. Doesn't look so good. What do we see on the address lines? Looks still like it wants to execute something. I wonder if we're now in the vicinity of a broken VIC. I do have a replacement character ROM. Let us quickly put that in, because with the character ROM it should at least display something with the DARE test or the DES test. I put in an EEPROM character ROM to see if that changes anything. Which is a good sign and a bad sign, because I think this might hint at a broken VIC-II. The CPU most probably was broken as well, due to the fact that it had this NMI toggling weirdly. That was definitely not a very sane CPU. But the DARE test doesn't do anything at all, as it seems. I would say this is slowly but steadily hinting at maybe a broken VIC chip. I will replace the VIC chip and try and see if that helps. Great! Next chip replaced, which is relatively easy, but I must say the sockets in this board are really crappy. I think this is even a single wipe socket. This is at least a dual wipe socket. And these are also single wipe, which are very terrible. It is inserted here. It is borrowed from a long board, so it should be compatible. Let's turn this on. And it still doesn't do anything. So maybe that's good news. Oh, we don't have a cartridge in, so there's no surprise there. Let's put a cartridge in. Without the ROMs, it is not going to do much. No, there's no help in that. I'm gonna insert the other ROMs so that we have a full set again, because I think those are not the culprit, or at least not at the moment. Ah, there you go. Let's swap back the VIC in a second. With the replacement char ROM and kernel and basic, it does boot up. So maybe the kernel ROM is necessary. Okay, this is looking good. Let us quickly swap out the character ROM for the original one. I did see character ROMs fail. Quite a bunch of times, actually. No. The original character ROM works as well. Which means that most likely the VIC chip is dead, which is bad news. We have a bad PLA, a bad CPU, and a bad VIC chip. Question is, maybe the SID chip is also defective. We'll figure that out in a moment. But the desk test max is running. I'm going to very quickly replace the VIC chip, just to make sure that it is the VIC chip that is bad. So there, in we go. And nothing. So I think we can safely assume that this VIC, sadly, has stopped working. Right. Next test will be the full diagnostic harness, including the testing of the SID chip. So I put that away. I will put in my borrowed VIC-II. And I'll hook up the harness and then we'll see. There we go. The harness is connected. The diagnostic cartridge is inserted. The harness tests all the ports. It might output some errors if the contacts here are too corroded, but I doubt it. I also tested again the old CPU and it does seem to work. We have to check if the NMI actually is working or not. So it does seem to be fine after all. Not sure about this sawtooth. Maybe it is on its way out. But I don't want to replace stuff that we don't have to replace right now. In the future it will be easy to replace this because it's now in a socket. So let's switch this on. Everything seems to power up. And it's also going. That is quite nice. It is testing the screen RAM now. Stack page and zero page was okay. There are no... Yeah, the CIA seem to be working. Both are counting up. You can see that in the bottom row. They have their timers running, which is a good thing because CIAs are also relatively expensive if you want to replace them. But the VIC-II will definitely be an expensive part to source. I don't have any. I do think I have one for the C128, but that doesn't help us here. The ROMs seem to be good. Cassette, keyboard, everything is fine. Interrupts, that's now interesting. If the interrupt is okay, I'm turning down the SID. It was quite loud, but the SID works, which is nice, and everything seems to be working. So, to recap, we definitely need to buy a new VIC-II. We have replaced the PLA, which was definitely broken, and we replaced these two MOS chips because they were still good, but they are always failing. It's just a matter of time. The CPU still seems fine, so nothing to replace there. Even the NMI is working. If it breaks down in the future, it will be easy to replace because I installed a socket. Probably was not really necessary, but yeah, I will report back to the owner that he needs to get a new VIC-II chip, and then he can decide if it's worth it to him or not. But I would say that's a successful repair. I'm gonna turn down the SID chip even further. Thanks for watching. Share, like, and subscribe, the usual stuff. You can follow me on Mastodon for more shenanigans like this. chaos.social/@root42. And yeah, please leave a comment about your C64 repairs experiences. This is definitely something special. I haven't seen that yet. I haven't had a broken VIC-II yet, but I do know that it happens. So that's interesting. The broken PLA, that was basically given because it's a MOS PLA, and they, I think from 1984, they always die. But yeah, other than that, this machine is in really nice shape, so I would love to see it restored to its full glory. And yeah, see you in the next episode. Bye!